Today, today I am going to talk about conservative force, non-conservative force, inertial frame of reference, non-inertial frame. This is for class 11. This is an important topic. In your class 11, it is dealing with inertial frame, but the questions are asked in your competitive examination on non-inertial frame. So this is a very important topic, and I want to clear all the words. Conservative force. It is a state function. That means it depends on initial and final positions, such as your gravity, force of gravity, your spin force, electrostatic force. These are all conservative force. It depends on the state, initial and final state. Whereas your non-conservative force, it is a path function. For example, your frictional force is a non-conservative force. Now, here comes our inertial frame and non-inertial frame. Inertial frame, it is a coordinate system where your frame is not accelerating. That means the body is at rest or is at constant velocity unless and until acted upon by an external force. That means it holds the first law of inertia. It holds the first law of inertia. So this is an inertial frame. It is just a coordinate system. And a non-inertial frame here, this non-inertial frame, if your car is accelerating or taking a turn, that means an accelerating frame is a non-inertial frame. An accelerating frame, it is a non-inertial frame. When your car is accelerating or when you are taking a round, here comes your non-inertial frame. Now, what happens next is your work energy theorem is applicable to all inertial frame of reference. But if we extend it to non-inertial frame, then a pseudo force is included, which is the net force on the body. Remember, when your work energy theorem is extended to a non-inertial frame, remember this, a pseudo force comes into existence, and that pseudo force is the net force on the body. And this pseudo force always act in an opposite direction to the acceleration of the frame. It's always acts in a direction opposite to the acceleration of the frame. It is because of your frame of reference is accelerating. So the non-inertial frame comes into existence, and your pseudo force, this is a fictitious force. This is a fictitious force which comes into existence when there is a non-inertial frame. And the pseudo force is direction is always opposite to that of the accelerating frame. Here it does not hold Newton's third law. It does not hold Newton's third law. So generally you have studied force. It is due to interaction of two bodies. Either you kick a football or a collision between the two bodies. There comes the force. It is because of the interaction of the two bodies. But here, this pseudo force, it is a fictitious force. That means it comes only when there is when your frame of reference is accelerating, that is in a non-inertial frame. So let me explain it by the help of an example. Let us take a person in an elevator and he is moving upwards. So we are going to consider two frame of reference. One is the inertial frame of reference and another is the non-inertial frame of reference. Now a person in an inertial frame of reference is at stationary, he is standing there and he is looking at the elevator which is moving upward. Now here you see that when a person inside an elevator, he is moving upward. A person and another person who is in an inertial frame, he is at rest. He views the or he looks at the elevator. A person is inside it and the elevator is moving upward. Now here you see the forces acting, the weight of the body which is acting downward, and the floor of the elevator, it is acting upward, that is the reaction, because according to Newton's third law, to every action there is an equal and opposite reaction. So now the net force acting on the body, the net force acting on the body is the normal reaction minus the weight of the body. Normal reaction minus the weight of the body. Why? Because the lift is moving upward. So your normal reaction must be greater than the weight of the body. And this is the net force, and this net force will be equal to mass into acceleration, that is the mass of the person inside the elevator and the acceleration with which the lift is moving upward, and the acceleration with which the lift is moving upward. So your net force will be mass into acceleration, and this will be equal to normal reaction minus your weight of the person. So here you see that your normal reaction, that will be equal to, that is now your normal, because your net force on the body, that is m into a, where a is the acceleration of the elevator and m is the mass of the person. So ma will be equal to the normal reaction of the lift minus the weight of the person. So if you shift this mg to the other side, your normal reaction will be your normal reaction will be ma plus mg. So here you see that the weight of the body increases because your normal reaction is equal to ma plus mg. So your weight of the body increases. And so here we find that the lift is doing two works, that is, it is lifting the person as well as it is lifting the elevator to upward. This is for an inertial frame. Now let us move to an non-inertial frame. Here the person inside the elevator, it is moving upward. So the person is stationary with respect to the surrounding, that is your surrounding is the elevator. Here it is a non-inertial frame because the person is inside the frame and the frame is accelerating, that it is moving upward. So the person is in a non-inertial frame. So here the net force is zero. The net force is zero because the person is in equilibrium. That means the person is stage is stationary with respect to the surrounding. Your surrounding is the elevator. Your surrounding is the elevator. Now the force here is the normal reaction minus your weight of the body. And one more force comes into existence, that is the pseudo force. And this pseudo force, I have already told you, this pseudo force is the net force, it is the force acting on the body. It is the force acting on the body. And this force will be in a direction opposite to the accelerating frame. So your accelerating frame acceleration is A, and since your pseudo force, that is the fictitious force, your pseudo force, it is because it is in a non-inertial frame, And so to balance it, a pseudo force comes into existence here, pseudo force. That means your net force now will be the normal reaction minus the weight of the body, the person, minus the pseudo force. And your net force is zero. Why? Because the person is in equilibrium, because is equilibrium with the surrounding. He is stationary with the surrounding. The person is stationary with the surrounding. So the person is stationary with the surrounding. So a pseudo force comes into existence. And I have already told you that the pseudo force, it is the force acting on the body. It is the force acting on the body, which I have already told you in work energy theorem. That means the pseudo force is acting on the body, and that pseudo force is direction is opposite to the direction of the accelerating frame. So now your force will be normal reaction minus weight of the body minus pseudo force, that is minus ma, and this is equal to 0 because your net force is 0. Now you move both mg and ma to the other side. Here you find that your normal reaction will is equal to mg plus me. So in the inertial frame as well as in the non-inertial frame, we get the same result. So this is the difference between the inertial frame and the non-inertial frame. To apply so so that we can apply Newton's law. So that we can apply Newton's law, a pseudo force comes into existence, and that pseudo force must be opposite to the acceleration of the frame. So this is the difference between the inertial frame and the non-inertial frame. Let me extend it another example. When a person is accelerating, when a person is driving a car, and the person who is driving a car, when the car is accelerating, that means it is in a non-inertial. The person is in a non-inertial frame. When the person who is driving the car, it is accelerating. There is a backward push in the seat. There is a backward push in the seat exerted to that driver. So this is the pseudo force. So this is the difference between conservative force, and remember, conservative force or non-conservative force, they are applicable to all frame of reference. They are applicable to all frame of reference. So this is a simple topic, but it is very important to make you clear what is conservative force, what is non-conservative force, what is a uh, inertial frame of reference, what is non-inertial frame of reference, what is pseudo force, and what is the direction of the pseudo force. So this is a very important topic for class 11 students. That's all. Thank you.